Students, I am going to discuss a problem of fluid mechanics. The specific topic is Torricelli theorem. The problem is a tank is filled up to height h with a liquid and placed on a platform of height h. Find the position of the hole in the tank or the maximum range of the liquid and the maximum range. Okay. Now here you have a tank filled up to height h. Okay. And the platform is height h. The range of the liquid is at x. Suppose the position of hole is at a depth y below the free surface of liquid. So the velocity of flux through the hole VE is equal to under root 2GY. Okay. Now the time the liquid takes to fall this height, that is this height is equal to this height. This is 2h minus y. So up to here is 2h and this is y. So it is 2h minus y. So we can write by using second equation 2h minus y is equal to 0 plus half gt square. Okay. So t is equal to under root 2h minus y upon g. Okay. So this horizontal range x is equal to horizontal range x is equal to the velocity of flux VE and the time the liquid takes to find all this height. Okay. So it will be under root 2GY into under root 2h minus y on g. So it will be 2 root y into 2h minus y. Okay. Now to get a maximum value of x, differentiate this with respect to y and put equals to 0 or maximum value of x dx over dy is equal to 0. Okay. So you differentiate it and put equals to 0 or this 2y to the power half and 2h minus y to the power half with respect to y is equal to 0 and 2 get multiplied by here, so it becomes 0. And so using the formula of product of the two functions. So first function differentiation of second, that equals to half into 2h minus y and minus half into minus 1 plus then second function 2h minus y half into half y minus half. This is equal to 0. Okay. On simplifying, we have y is equal to h. Okay. Now substituting the value of y in this equation, so x max is equal to to 2 times this is root h 2h minus h. So it will equals to 2 times h, and this h, and this is, so it becomes 2h. Okay. And thanks for watching the video.